So when we look at u-substitution, we've looked at u-substitution with indefinite integrals. Now we're going to look at u-substitution concerning definite integrals. And definite integrals are, of course, where we have the limits of integration here on our integral sign, right? And so how do we go about doing this? There's one thing we have to pay close attention to, okay? It's just one little minor difference when we do the u-substitution with definite integrals. So let's just read here the notes. It says u-substitution with definite integrals is very similar to u-sub with indefinite integrals. The limits of integration need to be considered. What we have to realize is that when we use u as a substitute variable for x, the x expression, the limits of integration change. And that's the big thing. You don't want to get these values, in this case 1 and 2, you don't want to get those mixed up. You have to remember that those are x values. Okay? So the limits will be x values, not u values, and this is an important consideration. So here's how we tackle this. Now I'm not going to go into how we integrate this with u-substitution, because that should be something that we are aware of. And my computer just froze. Give me 1 second. Okay, so we've learned how to do that already, and so I'm going to skip that part. But watch what happens here. Okay, so when you take the integral, so we're going to evaluate this right here, or at least simplify this using u-substitution. This is what we end up with right here. We end up with the u to the 4th du, and we did this yesterday in class. Now, here's the thing. You cannot write this step with the same limits of integration here. You can't. Because these are x equals 2 and x equals 1, and we don't have an x anywhere in the integral. Okay? So that's the first thing. You can't actually write it like that because this is not an accurate statement then. But the other thing is that you might save yourself some time if you convert these limits of integration into basically u values. Okay? So that's what we want to do. Now let's just scroll down here a little bit. So in u-substitution, okay, let me just erase this so it's not too confusing for you. Whoa, that's too much. Okay. All right, so we're looking for this one and this one. In u-substitution, the limits of integration must change because the limits are x values. So you would never see x limits of integration in an integral with u. So look at this. When x equals 2, and that was the upper limit of integration here, what is u? Well, u is 3x minus 2. So we simply substitute. When x is 2, u is actually 4. So guess what? The 4 goes in here as our upper limit. When x is 1, u is 1. And so 1 goes here. So this is really important. It seems pretty minor, but it's actually quite important. So the limits of integration actually change, okay, when we simplify this integral. And now, though, what you can do is you can take the antiderivative of just u to the 4th. You don't have to worry about the 3x, minus 2 part. You can just take the integral of u to the 4th, and that's just 1/5 u to the 5th, right? And we're going to evaluate that here from 1 to 4. So a definite integral, right, gives us a definite number, and we're going to do 1/5 4 to the 5 minus 1/5 1 to the 5th. Okay? And so if we do that, well, I can do that on my calculator too. Okay? So 4 to the power of 5 is 1024 divided by 5 is 204.8, and 1/5 is 0.2. Right? So that's 1 to the power of 5 is just 1. So 1/5. So this is 204.6. And that would be our value for our definite integral. So I just, over here, I sketched this graph earlier, and I just sort of approximated, before I even did this question, I just approximated what I thought a reasonable answer would be. And I came up with somewhere around 200. And so again, you're looking for exactly the area, in this case, we take a look at the integral as area, the area underneath this curve between, 1 and 2. So I'm looking for this exact area. I just estimated the area of this triangle, and I got about 200. So that's reasonable. All right? So again, the big thing is changing the limits of integration when you go to u. Now, if you didn't want to do this, guys, okay, if you didn't want to do this little step here, you could, okay, substitute u back in here and keep the old limits. Like I say, I don't know. This definitely, step right here, this definitely is easier than having 3x minus 2, I think, in there. But you're almost doing the same amount of work. You're just kind of doing it at a different part of the question. So let me just try and explain what I mean here. If you get to this u part, and let's say we still had x equals 1 and x equals 2, and you wrote that and you were clear on that, then you could say, hey, I'm going to leave those limits, 1 to 2, and I'm going to write this as 3x minus 2 to the power of 4 dx. Okay? So you could do that, and then you would have to take the integral of this. Now, right, that would be a little bit tougher. At this stage, you could go, hey, here's the integral, 3x minus 2 and to the power of 5, and I'm going to evaluate from my x limits, 1 to 2. Okay? So this should work as well. So 1/5, I'll just show it here real quick, 3 times 2 minus 2 to the power of 5 minus 1/5, 3 times 1 minus 2 to the power of 5. And so, hey, this is 3 times 2 is 6 minus 2 is 4. That's 4 to the 5. It's the same. See that? So you're just kind of shifting the work a little bit later. But you will see in the AP exam, okay, if you're taking the AP exam, you'll see that the limits of integration change all of a sudden, and this is why, okay, when you do a substitution part in the integral. All right? But just please don't get confused with these limits, because I've seen students do that before. So that's what I wanted to focus on there today. All right? This is fine, and this is fine. Just don't mix up these numbers here, okay? Any questions? Okay, so I've given you some questions in your textbook there to work through. Let's see, I don't have that up anymore. Okay, I'll get that textbook up, and I'll just kind of show you that chapter 11 part. Yeah, so here's your assignment questions. I think I gave you some from number 2 and number 3. And now you can do some from number 4 as well. So you see these are definite integrals, and yeah, you can get some practice here. So why don't you do A, C, E, G, and number 4 kind of as a minimum practice as well. Okay, so I'll show you the answers here too on the video for questions in number 4 there. So let's see. So here's 4A, B,